Identification of sodium ion. This is today's lesson. In this lesson, we are going to learn how to identify sodium ion in its solution. So, let's begin. Identification of sodium ion. For this, we are to take 2-3 milliliter of sodium ions solution of sodium salt. Sodium ion is present here. Sodium salt may be sodium chloride, sodium carbonate, etc. Solution of sodium salt. Here, in another test tube, we need solution of potassium pyroantimonate. This is another test tube in which solution of potassium pyroantimonate is present. Now, solution of potassium pyroantimonate. 2-3 milliliter of potassium pyroantimonate solution is added to the solution of sodium salt. With the addition of this solution, in this solution, white precipitate is formed. This white precipitate confirms the presence of sodium ion in the solution. This is wet test, but before this, dry test. Dry test is flame test. Sodium ion, that is sodium metal, in flame test produces golden yellow color. Dry test. Now, wet test. This is wet test, in which, with the addition of the solution of potassium pyroantimonate to the sample solution, then white precipitate is formed. This white precipitate confirms the presence of sodium ion in the solution. Now, let us try to know the reaction to form white precipitate and the reason behind this. Now, let us see the reaction to form white precipitate. Salt, suppose sodium chloride. Solution of sodium salt, sodium chloride solution. Here, solution of potassium pyroantimonate is added. Solution of potassium pyroantimonate. Then and there, white precipitate of sodium pyroantimonate is formed. Solid, white precipitate of sodium pyroantimonate. Then, potassium combines with anion of the salt. Here, potassium chloride. This white precipitate of sodium pyroantimonate confirms the presence of sodium ion in the solution. Now, let us try to know why this is soluble in water, but this is insoluble in water. Sodium pyroantimonate. Firstly, let us see potassium pyroantimonate. This is potassium pyroantimonate, which is soluble in water. We know sodium is above potassium in the periodic table. So, sodium is a bit smaller than potassium. It means in case of sodium ion, charge density is higher, but in case of potassium ion, comparatively charge density is lower. That is simply in sodium ion, charge density is higher. In potassium ion, comparatively charge density is lower because potassium ion is bigger in size compared to sodium ion. So here, in case of potassium ion, charge density is lower. That is, here the attraction force will be lower. It means hydration energy is higher than lattice energy in case of potassium pyroantimonate. Charge density of potassium ion is lower, so lattice energy is lower, but hydration energy is higher. Here, hydration energy can overcome the lattice energy. For this reason, potassium pyroantimonate is soluble in water. But in case of sodium pyroantimonate, here sodium pyroantimonate. In this case, charge density of sodium ion is higher compared to potassium ion. As it is higher, here lattice energy will be higher than hydration energy. In this case, lattice energy is higher than hydration energy. Hydration energy cannot overcome the lattice energy. For this reason, sodium pyroantimonate deposits as precipitate, white precipitate. This white precipitate of sodium pyroantimonate confirms the presence of sodium ion in the solution. Thanks for watching.